So this video is about what we call similar figures. It's figures or like shapes or anything that are similar. Like they're kind of the same, but not exactly. Meaning they are the same shape, but they might be different sizes. If they are the same size, we call those congruent, and we'll get to that. Sorry, those are not quite the same, but you get the idea. If they're congruent, they are also considered similar because they're still the same shape, although similar figures typically are different sizes, but they don't have to be. So with similar figures, all the corresponding angles in a shape are actually still the same. So like angle A here and angle D are actually still the same. And B and E are the same, and C and F are the same. Those angles don't change, they just kind of like extend a little further, but the corresponding sides are not the same. They have the same ratio though, because the figure has been dilated in some way, either stretched or shrink. For example, 7 to 14 is the same ratio as 10 to 20, which is the same ratio as 6 to 12. All of those are equal to each other, they're all just 1/2. You could have flipped that and done like 14 to 7, 20 to 10, 12 to 6, same idea. But they have the same ratio, and because of that I can tell that they're similar figures. So two figures are similar if one is a transformation of the other. Typically it's a dilation, so like a stretch or a shrink, although it could be also a rotation, reflection, or translation. In that case it would be congruent, but again, congruent figures are still similar because they are still the same shape. So, why are these similar? They are similar because, like I just mentioned, if you compare all the corresponding sides, they have the same ratio. So this will allow us to solve for some missing side lengths or maybe even missing angle lengths. For example, in this triangle, if I want to find n, which is what this asks me to do, then I can do that. I'll need to explain these symbols a bit. This means triangle ABC and triangle DEF, and this little squiggle here means that they are similar. So not congruent, but similar. So that means the corresponding sides should have the same ratio. Whatever the ratio of 3 to 12 is, that should be the same ratio as n to 8. Those should equal each other. Don't know exactly what it is, you could probably figure it out. It's not that crazy to be like, oh look, multiply by 4, so what multiplies by 4 to give you 8? So if you want to do it that way, that's fine, but I can set up these ratios like this. Also, by the way, how did I know that AB corresponded to DE? I know it kind of looks that way, but sometimes these are a little tricky. So I do want to be clear, when you write out this kind of thing, the letters should line up. So AB should correspond to DE, and BC corresponds to EF, and AC corresponds to DF. Like the order you put those matters. Okay, so let's say I couldn't quite figure out that it was like, oh look, multiply by 4 or divide by 4. If I wanted to solve this another way, I could cross multiply. So 3 times 8, which is, well, 3 times 8 equals n times 12. So that's 24 equals 12n. Divide by 12, and you get 2 for n. So n is 2, which makes sense, because 2 times 4 is 8, and 3 times 4 is 12, so it was a scale factor of either 4 or 1/4. Let's try another one. Again, it says these two triangles are similar. We've got the little triangle within the bigger triangle, and I want to find x. So This one's going to be a little harder to figure out maybe, and so I'm going to set up some sort of like ratio. I know that 17 and x go together. You can do either x to 17 or 17 to x. It doesn't matter. I like to put the variable on top, so x to 17. But I need to keep in mind that I just went big to small. So this was big and this was the small triangle. I'm not going to be able to solve x over 17, so I need it to equal something. Basically, I need to pick another ratio from these two triangles. So if I went big triangle to small triangle, what's another ratio that I have here? You're going to need to do a little bit of adding. What is the length of this long side of this triangle? Well, that would be 15 plus 10, so 25 is the length there.
Teachers, pardon interruption. At this time, if you could release all football players. Thank you.
So this big length is 25, and the small triangle is just 15. So it's 25 to 15. All right, that's actually all that I need to solve this because I can now cross multiply, but I do want to just show you that I could have used this ratio as well. I could have used this long side would be 12 plus 8, which is 20. So 20 to 12 I could have used as well. 20 to 12 should be the same ratio as 25 to 15, and if you'll simplify, you'll see that it is. Okay, so I'm just going to use this, do a little cross multiplying. So 17 times 25 should equal x times 15, or 15x, and then divide both sides by 15. I'm just going to do all that in my calculator. So 17 times 25 divided by 15 is 28 1/3, or 28.3 repeating, or 85 thirds. Any of those are fine. Equals x. Let's make sure that makes sense. If this is 28 1/3, that is a little bit bigger than 17, so that makes sense. All right. I want to show you one final thing which, remember, all the corresponding sides have the same ratio, but the angles are always the same. So for example, if this one had an angle that was 30 degrees, and I was like, what's angle D? It's tempting to be like, oh, it's twice as big, so it's 60. But the angles stay the same. This is still just 30 degrees. Or if this was 85 degrees, and they were like, what's angle F? Be like, well, it's still 85 degrees. That's it.